Okay, we're going to talk about the parts of the atom, and we're going to talk about something called cathode ray tube. Way back in the day when TVs were huge, they had these things called CRTs, and it was a ray that made the picture show up on the screen. So we're going to use this was used for chemistry a long time ago to find out the parts of an atom. So let's talk about the parts of an atom. So there's three parts to the atom. Remember, atoms are elements of the periodic table, and they have specific parts inside them. There's three kinds. There's electrons, protons, and neutrons, and this is another key thing about chemistry. We have to learn all this good stuff. So back in the day, they didn't know the parts, and they had to do experiments that they couldn't look inside the atom a long time ago, so they had to do experiments to figure it out. So J.J. Thomson did the experiment on figuring out the electron, and electrons are negatively charged. So he found that out by experimentation. And he passed electric current through gases at low pressure, and the result was this beam. They decided to call it cathode ray, and later on we could use it in TVs and computers, but he didn't know what that ray was when he did this experiment. He had to figure out what it was. So he saw this glowing beam, and this is the experiment he set up. He had a vacuum tube. He took away most of the gas out of it, all the air that was inside, he pulled that out. He had a positive metal disc over on the side, and a metal disc over here that was a negatively charged. This is called the cathode, so that's why it's called cathode ray. And then the anode part. So this side was positive, and this side was negative. He threw electricity through the gas. There was still some gas inside here. And then he was able to make this ray start. You could see this glowing ray. So J.J. Thomson did this, and then he did some experiments with it. He put a magnet right here, and he noticed that if he did that, the ray would start curving up towards it. And so because of that, he was able to figure out that the electrons were negative. He brought a positive plate up here, he put a negative plate down there, and the ray would start going towards the positive. So he knew that then the ray had to be negative, and because it was going towards the positive, because opposites attract. And he was able to figure out that that ray was actually electrons, and we know that electrons are part of the atom now because of J.J. Thomson. Another person worked with the cathode ray tube and found rays traveling in the direction opposite of the cathode ray, and he thought that those particles were probably positive because they were doing the opposite of what the first ray the cathode ray was doing. And he called those protons, and they are positively charged. And then the hardest thing to figure out was the neutron, because it has no charge, so it's kind of hard to do experiments if you can't make it attracted or repelled from something. So he figured out in 1932 the neutron, which is neutral, it has no charge, and it's part of the atom. And it has a mass, just as much mass as what a proton has, so they're really equivalent. So after they did all these experiments, this is what they found out. We give this symbol for electrons. It's got a 1 minus charge. It's very small. It's 1 divided by 1840. This is the mass. It's extremely small. And then protons have this, we call it a P and a plus charge. It's got 1 positive charge. We call it a mass of 1 for protons because it's a lot bigger than the electrons. And this is what it really weighs in grams. And then neutrons have no charge, so we put a 0 there, has no charge. It's equivalent to the proton. It has this mass. So these two are the same, but electrons are really tiny. So when we talk about the mass of an atom, we just care about these two things. We care about the protons and the neutrons. They're the one that make up the mass of an atom. Protons plus neutrons makes mass. So how can we describe the structure? How do we know where all those little parts of the atom are? So J.J. Thomson and others thought the atom was filled with positively charged material and the electrons were all the way through it, kind of like a chocolate chip cookie. You got the dough of the chocolate chip, and then like the electrons are the chocolate chips inside the chocolate chip cookie. And then my favorite chemist, Ernest Rutherford, started to do some experiments, and he's my favorite chemist, Ernest Rutherford. And here is his portrait on the New Zealand $100 bill, I think. Yeah, $100 bill. And I have a clock that my son made for me that looks just like that. And so I love Rutherford. He's my favorite. He's my fave. So he did this really cool experiment, and this is the reason I think I'm so in love with Rutherford. I was probably in 7th or 8th grade in the summertime, and I went to the library in Livermore, which is huge, and it's got tons of science stuff in there because it's near, Lawrence Livermore Lab is there, and so they love science there. And I opened this book, and I opened the book, I was reading, and I felt like the skies opened up and angels started singing, because I could understand this cool experiment that Rutherford did. And even though I was young, I read what he had done, and I could understand it. It was hard for him to do, but it was to the point where I could understand it, and I was so excited about chemistry at that point. So that's kind of where my love of chemistry came in. And then my dad would do experiments with me at home. So that got me interested in chemistry. So I love chemistry. And this is why. From Ernest Rutherford. He decided to do an experiment where he would take these particles called alpha particles, which are positively charged, and he started like bombarding a piece of gold foil. So gold, you can make it really thin. You can make it so thin you can put it on food and eat it. So like rich people like to eat food with gold all over it, like candy with gold on it. I don't understand why, but I'm sure it looks pretty cool, but I don't understand why you want to eat gold. But you can make gold really thin, like even thinner than aluminum foil. So he took that, he put it in the center here, and he put a screen here that could see anytime something hit it. So fluorescence. And then he took those positive particles, he shot them out of this machine, and he shot them towards the gold foil. Now the interesting thing is he thought that all of them would go straight through and hit the screen back there and you'd see them. But his experiment totally messed with his mind, and what he saw was little dots of fluorescence all the way around here. Most of the dots were here, but he saw every once in a while you'd see one over here. And it freaked him out. It took him a whole year to figure out what in the heck was going on. He was shooting positive beams at this foil. He thought all of them would go through because he thought the atom was a chocolate chip cookie. And so all of them should be able to go through. But, like I said, he saw some that were over here. And that freaked him out. So this is what was happening. He had positive particles, and he thought that the electrons were like all over the place, and the protons and the neutrons were all over the place. And if he shot a positive thing, they would go straight through. But actually, atoms have in the center the thing called the nucleus, and it's got positive protons and neutral neutrons. So overall, the charge is positive. So once these particles, positive particles, got close to one of these positives, it would get deflected. And he didn't understand that at the beginning. He had to think of why his experiment showed what it did. And he was able to figure out that, hey, the atom's not a chocolate chip cookie, it's got the nucleus in the center that's positive. So he figured out that the atom's mostly empty space, and that empty space is where the electrons are buzzing around, but the center is where the protons and the neutrons are, and that's where the mass is. So this experiment was very important, and I love this experiment. It's so elegant and beautiful. I just fell in love with chemistry. So I'm very thankful for Rutherford. So the nucleus is the center. It's got positive and protons and neutral neutrons, and overall it's a positive charge. So this is the key we need to know. So let's try our quiz. What's not a subatomic particle? Remember, sub means less than the atom, so smaller than the atom, just parts of the atom. So which is not part of the atom? So hopefully said molecule. All right. Question 2. The nucleus is made of what? Okay, this is what Rutherford figured out. So what do you think? All right. So it's protons and neutrons. So it's positive overall. Last one. Most of the volume is occupied by, remember we said it's mostly empty space, but the volume's occupied by what? Electrons buzzing around, and we'll talk about that in our next talk. All right, it was good talking to you. Talk to you soon. Bye-bye.